Hi everybody, my name is Nicholas. I'm a software developer at Rome Tools, and I'd like to talk to you all about why your CI is so damn slow. We've all been there. You've pushed your latest code to GitHub, your CI service is spitting up, and it's taking forever. You wait and wait and wait, only to get your result back 5, 10, even 20 minutes later. It's annoying, it's disruptive, it's a waste of your damn time. Normally, we just accept this as an eternal truth. CI is slow. I don't think that's okay. Having to wait for CI has a direct, dire effect both on your productivity and on your finances. Let's start with a resource that matters to all of us, developer time. I don't know about you all, but when I encounter a time sink, such as a slow CI, I do one of two things. I slack off or I start another task. Slacking off is clearly a net negative. Sure, we all deserve breaks, but not every single time we push up some code. Our CI shouldn't determine when we work or not. But Nick, you say, we could just start another task. And yeah, starting another task seems tempting. We're all capable multitaskers. Turns out, no, we are not. In the paper Task Interruption in Software Development Projects, the authors measured the effect of task switching on productivity. It wasn't good. In particular, they noted that self-interruptions, basically when you purposely switch between tasks, they tend to be more disruptive than external interruptions and lead to less task completion. With slow CI, this flow gets constantly interrupted. You end up switching between the CI jobs and your new task, losing your working context and therefore your efficacy and efficiency. Or worse, you get focused on your new task, forget about your CI job, and only remember a few hours later that your job is done. You ping your reviewer just to realize that they've gone home. Suddenly, a quick PR takes 2 days or more to merge. Even worse is when you have to debug a CI workflow. Whenever I have to debug one, it's so awful. I end up tweaking a setting, waiting for the job to complete, getting distracted, and only seeing the results 15 minutes later. A 15-minute development cycle is not acceptable in this day and age. But it's not just developer time. Slow CI means more compute time, which, as anyone who stared in shock at their AWS bill knows, means more money. One such example is the free desktop GitLab instance, which hosts a bunch of free software projects, such as Mesa, the Linux kernel drivers, and many others. They experienced a massive period of growth in the late 2019 to early 2020 era. However, their expenses ballooned accordingly, first at $75,000 in 2019, and then they were projected to hit $90,000 in 2020. They managed to cut costs before they ran out of money, but still, for an open source project, that's a massive amount to be spending on CI. Let's do better. Let's figure out why CI is slow. To do so, we should look at what a CI job does. At its core, there are two types of CI jobs, static and dynamic jobs. Static jobs apply developer tools, such as a linter, bundler, formatter, etc., to your code without executing the code. Dynamic jobs may also apply tools, but they have to run your code. We're going to focus on static jobs, but many of these lessons apply to dynamic ones too. Regardless, if your CI job is slow, it's likely because your tools are slow. But what do I mean exactly by slow? Of course I mean the tools are slow in their runtime. However, for CI, there's a second type of slowness. These tools are also slow in their installation time. Let's take ESLint. It's a great tool. However, like many tools in the JavaScript ecosystem, it has a lot of dependencies. This isn't a dependency shaming talk. I use dependencies, you use dependencies. They're a necessary part of modern software development. But dependencies do have an impact on your CI. Namely, you have to install them. And no one likes waiting for NPM or yarn to do its thing. And with JavaScript, there's always the biggest dependency of all, Node. You have to download this massive runtime just to run your other dependencies. How many times has a CI service had to spin up a Docker container with Node just to run a tool like ESLint or Webpack? And back to running time, why are these tools slow to run? At Rome, we've put a lot of thought into this question. First, and most obviously, it's because most tools are written in JavaScript, and JavaScript is not the ideal language for developer tooling. It uses a lot of memory, it's hard to write safe concurrent code, and it requires a runtime. The solution is, well, don't write the tools in JavaScript. We use Rust, ESBuild uses Go, Bun uses Zig. In our case, we found that Rust has given us significant benefits. We first wrote Rome in TypeScript. With this original codebase, we had to squeeze out performance with carefully optimized JavaScript and our own low-level primitives. In Rust, we got very good performance right out of the gate. Second, because Rust compiles to a static binary, we no longer have to install dependencies in our CI process. We can simply download a binary. And finally, there's an aspect to JavaScript tooling that we believe is underestimated. That's the problem of redundant work. The JavaScript tooling ecosystem is extremely fragmented. We use different tools to lint, format, bundle, and so on. Each tool, therefore, needs to parse and represent the JavaScript as a syntax tree. If you remember your compilers, you'll recall that syntax trees take up a significant amount of memory. Ever wonder why IntelliJ is slow? It's storing all these syntax trees. Not to mention, parsing involves I/O, which always comes with its own overhead. Therefore, each tool needs to do this work. Use 3 tools, that's 3 times the parsing time and 3 times the memory. With Rome, the goal is to have one tool that handles linting, formatting, bundling, and so on. That means 1 parsing stage and 1 syntax tree. There's no wasted compute and no wasted memory. With all this in mind, what does our ideal CI job look like? In the case of static jobs, these jobs should operate as native programs with no JavaScript runtime involved. There's really no reason to run Node or Docker for a linter or bundler. They can be used from the command line or as an API, in which case the performance expectation should be on par with any other REST API. You call it, get a result in under a second. Of course, for dynamic jobs where we need to execute the code, we can still spin up a runtime. But perhaps we can stick to more lightweight environments. Something like an AWS Lambda or a Cloudflare worker could easily suffice. So where does Rome come into this? For now, we're focused on delivering fast, native JavaScript tools. Our long-term plan is to be the one-stop shop for all of JavaScript. Hopefully, in the future, these tools will be the replacement for static CI jobs. But where do we start? Of course, we couldn't tackle every tool simultaneously. So we decided to do some research, look at open source repositories, and see what was slow in their tooling setup. We found that linting was generally pretty slow. But in particular, one rule stood out: prettier. If you're not familiar, there's an ESLint rule that checks if your code is formatted correctly by running prettier on your code and seeing if anything changes. In the case of Babel, the JavaScript compiler originally written by Rome's founder, Sebastian, the prettier ESLint rule takes over 6 seconds to complete. With Webpack, this rule takes 5 seconds. Maybe saying at this point, 6 seconds, that's not that much, and I'd agree in abstract. But in reality, 6 seconds is the difference between running your linter as a local watcher and running it on CI. If it takes 6 seconds to get your lint results back, you're probably not going to have the linter integrated into your development flow. You're probably not going to want to call it through a REST API. Instead, you're going to rely on running it as a CI task. You're going to wait longer before seeing potential issues in your code. With this evidence in mind, we made it our mission to make formatting better. Don't get me wrong. I love prettier, but it can get remarkably slow in large files. In particular, we were inspired by Rust Formatter, which is super fast. We decided that we want a formatter with the same level of performance, but for JavaScript. We also want a formatter that was integrated into your development environment. One particular feature of developer tools that we love is called error tolerance. A tool is error tolerant if it works even when your code has errors, whether they're syntactic or semantic. We put a lot of work into making the formatter error tolerant. That way, it can still make your code look good no matter what. We're super excited to announce that our formatter will be released by March 28th. We'd love to give a sneak peek of the performance of our formatter. First up, we have Dojo, a front-end framework. Running the formatter on a bundled library, prettier takes 75 milliseconds, which is not bad, but Rome is all the way down at 10 milliseconds. For Svelte, prettier is up to 750 milliseconds, almost a second, while Rome is all the way down at 200 milliseconds. And finally, there's the behemoth that is TypeScript's checker.ts, clocking in over 44,000 lines, or 2.64 megabytes. I don't know if you've ever opened this file in an editor, but I'll tell you now, it slows mine down to a crawl. Prettier takes over 2 seconds to format this file. We do it in 335 milliseconds. But that's just the beginning. Our next goal is linting. As I mentioned before, linting is quite slow in JavaScript. ESLint can easily take 15-30 seconds to run on a top computer. We want to be a tenth of that. Linting will also let us show off the power of our concrete syntax tree, or CST-based parsing. Once again, if you're familiar with compilers, you may know that parsers generally produce what's called an abstract syntax tree, or AST. ASTs are great because they abstract away unnecessary details such as whitespace or comments. However, it turns out that these supposedly unnecessary details are rather important for other developer tools. Specifically, it's really hard to do something like parse the code into an AST, modify the AST, then convert it back into code without completely rearranging the code, thereby creating a massive Git diff. With a CST, everything is preserved, comments, whitespace, everything. That means converting a CST back into code with only a minimal diff is extremely easy, which in turn opens up a whole host of powerful code modification features. We're really excited to demonstrate the possibilities of CST-based linting. Our linter will come out by the end of Q2, and we're so excited to demonstrate the possibilities of cross-language CST-based linting. To recap, CI is slow because our tools are slow, both in their installation time and in their running time. They are slow because they use slower languages that rely on runtimes and containers. To make CI faster, we need fast, native tools for JavaScript. If these goals sound interesting, we're going to be hiring soon. Feel free to reach out at nicholas@rometools.com or via Twitter. Thank you.